And escalate our privileges. So we want to be able to figure out how we can snoop around a system or take control of a system. And we need to know what the password is for. Typically, passwords are the first is a variety of different tools that we're going to be using and actually seeing some has to have a password, or you run into them at least once. Letters, numbers, symbols. We all know that longer is better. Why is it better? Well, it takes longer. All their resources on cracking some password of yours. Sure, they could probably crack most people's passwords, but they have a lot better stuff to be doing, to be honest. One thing that a lot of people don't realize is when you see or hear about these password cracking techniques where they're guessing a billion guesses, it's not like logging into a web page and trying your username and password on Gmail's login screen a billion times a second. That's an online portal. You're trying to log in, there's no internet connections that fast. What they're talking what's called a password hash. And a password hash is the plain text of a password. Let's say it's chicken, CHICKEN. When stored in Windows or in other directories, it gets hashed when it's in, a stored mode. Hashing is a cryptographic algorithm that converts data, specifically being a password, into a fixed length string of characters called a fingerprint. So it looks like a code. It could be uppercase, lowercase, just a whole bunch of random, looks like garbage. Now, they use a specific algorithm to compute what that looks like. Windows, at least for one, does. And that's an advantage, and we have tools that we can actually use to decrypt. Immediately. It'd be the worst security consultant on the planet. Now, another way of actually protecting stored passwords is to random text that gets added to the hash. So that way, if I were to use the same algorithm to encrypt your password, which is chicken, and let's say there's another user in Denver who has the same password of chicken, that password, when it's hashed, is going to look the exact same because it's the same algorithm changing the same word into the same cryptographic fingerprint. If I were to use assault, your password and my password would look completely articles, security articles about breaches and things like that. They'll note whether they were stored in plain text or whether they were stored and hashed, salted, so on and so forth. Because basically, even if you knew that you and I had the same password, and even if you could generate 1 million guesses a second, it would take billions of years to try and crack some of these password lengths, just based on the way these algorithms work. It's kind of cool. Another style of attack is, so let's say the most common 1,000 passwords in the world are admin, secret, password, love, hate, sex, so on and so forth. People have already assembled word lists for guessing. Hash tables of what those words already look like as hashes. So instead of your program or whatever you're using trying to take every word in a word list, convert it into a hash, and then compare that hash to what is in the file that you're checking, it's already done half of the work. So you can actually download rainbow tables, which are just huge lists of hashes, and run that against what you're trying to crack. And this is why people salt passwords, because it further ado, I think we are going to take the next lecture, which is going to be a demo of cracking some Windows passwords and some different ways and different techniques that you can do, and go from there. And that way you'll have something that you can practice and try in your lab and crack some of your other victim machines. I'll see you in the next one.